July 1st, 2025. A telescope in Chile spots something strange. October 3rd. It passes Mars at 29 million kilometers, close enough for our robots to photograph. But something's wrong. The mass doesn't make sense. The chemicals suggest planetary origins, not deep space. The path aligns perfectly with our solar system's plane. Probability 0.002%. Solar storms that should destroy it barely leave a mark. A famous Harvard scientist says there's up to a 40% chance we're looking at technology from another civilization. December 19th, it reaches Earth. Then it's gone. They call it Atlas, the third interstellar visitor we've ever detected. The first two were strange enough. This one breaks every rule. The Atlas Survey Telescope caught it first. 17.5 magnitude, barely visible. Within days, scientists confirmed what terrified them. It was active, releasing gases, building a cloud around itself, 6.4 astronomical units from the Sun. That's beyond Jupiter's orbit. Comets don't activate that far out. Then came the weight calculations, 73 trillion kilograms. Think about that number. Our most powerful rocket weighs 12 million kilograms. Atlas is 6 million times heavier. When comets release gas, they get pushed around like balloons losing air. Not this one. The jets barely change its path. Here's what should disturb you. Based on known interstellar matter density, we should have seen hundreds of smaller objects before finding something this massive. We haven't. Harvard's Avi Loeb ran the calculations. There simply isn't enough rocky material drifting between stars to explain an object this heavy arriving in our solar system. The timing gets stranger. They found pre-discovery images from May. The test satellite had photographed it months earlier. Nobody noticed until after the Chilean discovery. But the wait is just the beginning of what makes scientists nervous. October 3rd, the moment scientists had been waiting for. Atlas crossed within 29 million kilometers of Mars. That's close. Close enough for detailed observation. The European Space Agency deployed everything they had. Mars Express, ExoMars Trace Gas Orbiter, both locked onto the target. The KSSIS camera caught it first, a streak moving across the Martian sky. Not a star trail, something else. The images showed a massive cloud surrounding a central body. Scientists measured the coma, 26,400 kilometers wide. That's twice Earth's diameter. A bubble of gas and dust larger than our entire planet. Then they analyzed what was inside that cloud. This is where it gets disturbing. Carbon dioxide. Lots of it. 348,000 kilometer radius of CO2 gas. That's unusual. Most comets are dominated by water ice. Not this one. High levels of nickel too. Nickel suggests planetary origins, like chunks blasted off a planet's surface. Not icy debris from the edge of a solar system. The ratios don't match anything in our comet databases. The spectral signatures look wrong. Like this object formed in conditions we don't fully understand. They found cyanide, carbon monoxide, expected in comets, but the ratios were wrong. The environment around Atlas resembled conditions near Mars, not conditions in deep space where comets form. The chemistry tells a story that doesn't fit the natural comet narrative. Think about what that means. September 25th, a solar storm slammed into Atlas. Scientists predicted fragmentation. These storms tear comets apart. The radiation should have vaporized surface materials, changed the coma dramatically. They watched, waited. September 27th, observations showed nothing dramatic. October 2nd, still intact, no pieces breaking off, no sudden changes, just gradual expansion of the envelope, like it was shielded somehow. What's protecting it? Then came the polarization data. When sunlight hits comet dust, it creates a measurable pattern. Every comet ever studied shows positive polarization at large angles. Every single one. Atlas shows negative polarization, negative 2.77% at 6.4 degrees. That's unprecedented. The dust particles around it are fundamentally different, rougher, more irregular, or made of materials we've never encountered in any comet. The Hubble telescope captured something else. July 21st images revealed a teardrop shape. Not the round nucleus you'd expect. Elongated, stretched, like other mysterious interstellar visitors. The trajectory reveals something even stranger. The path Atlas follows through space tells a story, and it's not a comforting one. Most objects from interstellar space arrive at random angles. They come from any direction, any inclination. Atlas doesn't. It travels almost perfectly aligned with our solar system's orbital plane. The plane where all our planets orbit, 5-degree inclination. The probability of this happening by random chance? 0.002%. That's 1 in 50,000. Random chance? Or something else? It gets worse. Atlas didn't just pass Mars, it timed its arrival to encounter multiple planets. October 3rd, Mars. October 30th, it reaches perihelion. That's closest approach to the Sun. 1.4 astronomical units, just inside Mars' orbit, March 16, 2026. It passes Jupiter, 54 million kilometers away. Think about this from an engineering perspective. If you wanted to study multiple planets efficiently, how would you design a probe? You'd keep it close to the orbital plane. You'd time arrivals to maximize encounters. You'd choose an angle that lets you observe asteroid belt transits. 5 degrees is perfect for that. That's exactly what Atlas is doing. The speed adds to the mystery. 137,000 miles per hour at discovery. 153,000 at perihelion. It accelerates and decelerates precisely, moving fast enough to circle Earth in 10 minutes. That kind of velocity, combined with 73 trillion kilograms, represents energy beyond anything humanity could produce. Avi Loeb points out something chilling. Atlas came from the exact direction where alien civilizations could have detected Earth passing in front of our Sun. They would know our planet has the right conditions for life. If someone launched a probe after observing Earth, it might have been traveling for thousands of years, waiting for the perfect moment to arrive. Size estimates keep changing. Early observations suggested a few hundred meters across, maybe a kilometer. Then scientists got better images, better data. The numbers grew. Current estimates put the nucleus at 5.6 kilometers maximum. 3.5 miles of solid material. That's larger than the asteroid that killed the dinosaurs. Imagine a mountain racing through space at 153,000 miles per hour. The Hubble Space Telescope captured the closest images on July 21st. The James Webb Space Telescope analyzed its spectrum on August 6th. Mars Express tracked it through October. ExoMars kept watching. The JUICE spacecraft will intercept it in November. Every observation reveals something new, something disturbing. December 19, 2025. Atlas passes Earth at 270 million kilometers, our last viewing opportunity. After that, it returns to interstellar space at the same speed it arrived, gone forever. We have weeks left to understand what we're looking at. Scientists use a term for events like this, black swan events. Something so statistically unlikely, it forces us to question our basic assumptions. Events that shouldn't happen in our lifetimes, or ever. When you stack up probabilities this low, when you combine this many anomalies, the natural explanation starts breaking down. Avi Loeb is direct about it. Anyone claiming Atlas is purely natural must explain all the anomalies through natural processes. The impossible weight, the unprecedented polarization, the perfect trajectory alignment, the multi-planet encounter timing, the planetary origin chemicals, the solar storm resistance, the suspicious observation patterns. So far, no one has explained them all. 7 anomalies, 1 object, no complete natural explanation. Here's the theory that keeps scientists awake. What if Atlas is a Trojan horse? Technology disguised as a natural object. Think about the perfect camouflage strategy. You wouldn't make it obviously artificial, you'd make it look almost like a comet. But not exactly. Different enough that careful observation reveals anomalies. Similar enough to avoid immediate detection. Close enough to natural that most observers dismiss it. If an advanced civilization wanted to study other solar systems, what better method? Send probes that look natural. They could drift between stars for millions of years, occasionally passing through systems like ours, gathering data, observing, recording everything. The 5-degree alignment makes sense for efficient planetary study. The resistance to solar damage would be expected from advanced materials. The unusual composition could indicate construction rather than natural formation. Hull plating instead of ice and rock. The European Space Agency is already preparing. Their Comet interceptor mission launches in 2029. It will park in space, waiting, ready to intercept the next pristine interstellar visitor. They're learning from Atlas, building systems to respond faster. Next time, they'll be ready to study it up close before it disappears. But what if the next one doesn't want to be studied? What if it's already here and we just haven't noticed yet? The Vera Rubin Observatory will change everything. When it comes online, it will detect interstellar objects we're missing right now. Dozens of them, maybe hundreds. Objects passing through our solar system invisible to current telescopes. Atlas might not be rare, it might be routine. Think about the implications. If interstellar visitors are common, how many have already passed through? How many are here right now, drifting between planets? We've only had the technology to detect them for a few years. Before 2017, we didn't know objects like this existed at all. Atlas will pass Earth in December. Scientists worldwide are racing to extract every piece of data before it fades. Every measurement, every spectral analysis, every photograph. The observation window is closing. After Atlas leaves our solar system, it returns to the void between stars. We'll never see it again. Never get another chance to understand what it really is. The questions it raises don't leave with it. If this object shows signs of artificial construction, what does that mean for humanity? Are we being monitored? Have we been watched for thousands of years? How many civilizations are out there, sending probes through the galaxy? And here's what should terrify you most. Atlas is leaving, but the detection zone it came from, that region of space where civilizations could observe Earth, more objects could be coming from there, launched decades apart, centuries apart, following the same path. Using our solar system as a waypoint, the next one might already be traveling toward us, moving through the dark between stars. We won't see it until it's close, until it's too late to prepare, until it's already here, studying us, watching everything we do, and we just ran out of